in this first lesson, we're going to have, 2 or 3 functions, and then we're going to add them, subtract them, multiply them, and divide them. So, if I have, f of x plus g of x, right? That's clear, right? If I have 2 functions, f of x plus g of x, if you see that, you know what to do. You take f of x, you take g of x, you add them to each other. Now, there is a more concise way of writing this exact same thing, and that is f plus g of x, right? So basically, these two mean the exact same thing. So whether I see the thing to the left or I see the thing to the right, what do? Oh, I take f, I add it to g. Same thing with a minus. F minus g of x, right? This means f of x minus g of x. Sometimes students get confused when they see 2 parentheses like this. They think there is some sort of multiplication happening. But no, the notation, the symbols, just means f minus g of x. And then here I can write f times g of x, f over g of x, and so on. Okay, so here, take a look at example 1. I have f of x and I have g of x. And I'm going to perform these operations on f and g. The first one says f plus g of x. So basically, I'm going to take one function, I'm going to take another function, and I'm going to add them to each other. So first, f of x, right? It's this one. 3x squared plus 7x. Plus g of x is this one. Okay? And then I just combine like terms here. So 3x squared plus 2x squared is 5x squared. 7x minus x is 6x minus 1. Right? Now, next, I'm going to do f minus g of x. So here, f of x is this. But now there is a minus, right? So I'm going to do minus another function. And here's where things get important, right? Whenever you have a minus and another function, you've got to put it in parentheses. And so g of x is 2x squared minus x minus 1. Now we're going to distribute this over, right? Just like we did in the last chapter test, right? So this is going to be 3x squared plus 7x minus 2x squared plus x plus 1. So let's see here. 3x squared minus 2x squared is 1x squared. 7x plus x is plus 8x plus 1. Okay, questions? Okay, let's do the next one. Now, the next one says to do what with these 2 functions? So I'm going to multiply this times this. Oh, boy. But it's okay because we can do this, right? Because we did chapter 5. So what are we going to do? I'm going to take this and I'm going to distribute it to each of these people here. So 3x squared times 2x squared, what does that give me? 6x? 4, fabulous. Plus, minus 3x squared times negative x minus 3x cubed. 3x squared times minus 1 minus 3x squared. Are we good with that? Now I'm going to take this term and distribute it. So plus 14x squared cubed. Thank you. What's the next one? Fabulous. Awesome. Okay, good. So now let's see if there's any like terms. 6x to the 4. Negative 3x cubed plus 14x cubed. That's 11x cubed. Negative 3x squared, negative 7x squared. Yep, and negative 7x. Okay, so this process isn't new, right? This isn't new. None of this is new. The only thing that's new is it's just telling you to put them together, whereas before I gave it to you, put together like that. Okay? Okay, the next one is f over g of x. F over g of x means I take f of x and I take g of x. Okay, that's it. Now, if there is the possibility of factoring things out and then canceling them, you have to factor out and cancel. But if you can't, you can't. Okay. However, there's one tiny little complication. The complication is this. It says indicate any restrictions on the domain. That's a lot of words for saying make sure the denominator is not 0. Okay. So in math, we know you can never have something divided by 0, right? This never is okay. So in the first 3 that we did we have any denominators with variables in them? No, so there was not a problem. This is the first time we have a denominator with a variable in it. So we have to just say where this is equal to 0. So what you do is the following. Because you have a denominator, you just take the bottom part and set it equal to 0. Okay, let's factor this. Can we factor this? This is, if you bring it over, x squared minus x minus 2. Oh, yeah. Okay, so you know how there's a 2 here? Remember the shortcut I showed you where you can multiply the 2 over here and then?
Negative 2 and 1.
Yes. So when you have a number in front of the x squared, you can multiply this here. And now you factor this. So find 2 numbers that multiply to negative 2.
Oh, sorry.
Yeah.
I didn't see that the x squared was 0.
Oh, okay. So x minus 2, x plus 1. But then we're gonna put in that 2 back, right? So then the first one I divide by 2, so I get x minus 1, 2x plus 1 equal to 0. So when I set these equal to 0, from here I get x equals 1. And what do I get from this one? 2x equals negative 1, x equals negative 1/2. Yeah.
What happened to the green 2 on the left side?
So this, because both of these can be divided by the same number, you divide both of them by 2, it goes away.
Okay.
Now, this denominator, you set it equal to 0, this is what you get. That means when x is 1, you plug it in, that'll make this denominator 0. That's not cool. When x is a negative 1/2, you plug it in here, that makes this denominator 0. Also not cool. These are restrictions. So whenever you have something in the denominator, you have to find where it's 0, and then you say comma or whatever. X cannot be 1. X cannot be negative 1/2. And then that is your final answer. Okay, let me repeat that. Whenever you get something in the denominator, you have to set it equal to 0, find the solutions, and then say x can't be that number, x can't be that number.
No.
Oh, no, I meant for it to be what did I do? I meant for it to be a semicolon.
Okay. So that's how you answer if it's a fraction?
Yeah. Okay. So here, f times g of x, these should have parentheses. Oh, where did the parentheses go? Okay, so let's do another one. We have f times g of x. So I'm going to multiply f of g f times g. Okay, so first multiply the x into here. Okay, so what do I get? 3x cubed. Right, and then the minus 4. So I get minus 12x squared. Oh. Yeah, minus 12x squared. Right?
Oh, I distributed it. She distributed the x versus then she distributed.
Did you go opposite?
Or I'm going like 3x and not like the middle.
Oh, that works too. In the end, it'll all turn out to be the same.
Okay.
Yeah. So plus 8x minus 4. So 3x cubed minus 14x squared plus 9x minus 4. Complicated. So here, f over g of x. F of x is this. G of x is x minus 4. Right? But now I have a variable in the denominator, so what do? Set the denominator equal to 0. X equals 4, so I say, okay, x cannot be 4. That is a restriction.
We always only set the bottom.
Just the denominator, yeah, because the denominator is the only problem. The top can be whatever it wants. The bottom may never be 0.
Does it matter what punctuation?
No. You don't like my semicolons? Do a comma.
It's like working backwards. If you start with it equaling to 0, and then whatever like number you would have
Yeah, exactly. And you say, okay, it can't equal 0.
Because if x equaled 4, it would make it 0. That's all.
Facts. Awesome. Okay. All right. So now, new notation. A little circle comes into the mix. What? Okay. Take a look at this. Oops. It's all of this. Okay. So now I've got f og. So basically it's f of g of x. Another way to write this is f of g of x. Okay? Okay. What is all this? Right? We are used to seeing just f of x, right? But now this x has been replaced by what? G of x. Okay, so what on earth is that? Did you guys do this in Algebra 1? I don't remember. I haven't taught Algebra 1 in like 20 years. Yeah.
You distribute the x.
No.
You multiply the inside.
No. No. Okay. Aha. It's brand new. All right. Let's do it. Okay. So here I have f of x and I have g of x. And I have to find f of g of x. Let's do it. Okay. F of g of x. Take a look. Let me write down here. Okay, this is what I need, right? F of g of x. Okay, do you see how there is f and g here? One is on the outside, one is on the inside. Which one of the functions is on the outside? F of x. So what I do is, on top of this, above this, I write f of x equals, and I just copy down what f of x equals. Just copy it down. I've done no math here. Now, take a look here. In going from the first line to the second line, in f of x, this x has been replaced by g of x. So, when I go over to this side of the equal sign, every time I see an x, it's going to be replaced by what? G of x. So let's start now copying over that f of x. F of x equals negative 3 times x. But that x is now going to be replaced by g of x. What is g of x in this problem? Negative x plus 8. And now this is f of g of x. You see that? All the x's got switched out for g of x's. This x went away. In its place, I switched it out with g of x.
Are we allowed to distribute that?
Now you have to distribute this. Okay. Distribute, so f of g of x is equal to 3x minus 24. Okay. Next, I want to find the next thing, g of f of x.
You have to do both?
Yeah, well, the problem says to do both. Okay, so what's the outside function now? G of x. So I just copy down g of x. Yes, you're going to switch them around. I just copied down g of x. And so look, think this out. X has been replaced by f of x. So in here, everywhere that there is an x, I'm going to replace it by f of x. So equal to negative. What's f of x in this problem? Negative 3x plus 8. Do you see that? This is essentially the same as this. It's just that the x has now been switched up for negative 3x.
But you
f of
keep
x.
that little minus sign?
No, now we're going to simplify. So g of f of x is 3x plus 8. So those two are the answers here.
They're not supposed to align, right?
They're not supposed to be. No, they don't have to do anything with each other. Yeah.
From like the first one, g of x and equals negative x plus 8, if you see that it's negative x, do you have to do that minus 8? Because it's negative.
If you could just see it from here to here,
Okay.
do it.
Okay.
When you get more like used to this, you'll see that you don't even have to write this top row. Then like you can just see it mentally. But in the beginning, we just write things out. Okay, so here, so I'm gonna find f of g of x. So again, the outside function is f of x. So I put f of x equals x squared plus 2. Now, x has to be replaced by g of x. So every place there is an x, I have to switch it out. Okay, what's g of x? X minus 6. So this is going to be x minus 6 squared plus 2. Okay, so let's simplify this now. X minus 6 squared, that's like x minus 6, remember? Plus 2. Remember this was on the test too? We had something squared. Okay, so when I FOIL this, x squared minus 6x minus 6x plus 36 plus 2, x squared minus 12x plus 38. Okay? Huh? Okay, next I want to find g of f of x. Okay, so outside function is g of x. So x is going to be switched out with f of x. So what do I write here? X squared plus 2 minus 6. So x squared minus 4. Sometimes one is more computation than the other. It's okay. I did that quickly. It's just so much fun. Huh? I've been writing since before you were born. I've had how old are you? I don't know, that much more practice than you have writing, I guess.
Sometimes we have to do the differences. Sometimes we have brackets instead. Do you do that for your
It's not wrong to do that. If it makes you see things better, do it. Yeah. Okay, let's move on. Okay, so 2 more. f of g of x. Okay, so we're going to do f of g of x. So I write f of x down. So x is going to be replaced with g of x. So this is 2 times, what's x going to turn into? X squared minus 3 minus 1. Okay, so only the x gets replaced, right? So make sure everything else you copy over. Yeah.
What if you like switch it around and plug the f of x into the g of x?
No, so if you're looking for f of g of x, you have to do it in the right order.
Oh, it's
They'll,
like
they'll,
different things.
mhm. So this is going to be 2x squared minus 6 minus 1. Yes. F of g of x, yeah. Okay, next I want g of f of x. So let's write g of x up here. So look, x becomes g of x. So this is x. So only that gets switched with 2x minus 1. And everything else just continues as is. Okay. We have another one where it's squared, right? So look, remember here too, it was squared and we wrote it twice and we foiled it. You guys want me to show you the shortcut? You know, but you forget. Okay, here's the shortcut. You square the first term, what do you get? 4x squared. You square the last one, what do you get? Plus 1. Fabulous. Inside, this number 2 times negative 1, negative 2, times 2x, negative 4x. You can always do FOIL. This is faster for me, minus 3. This number, that's exactly what it is. It's the perfect structure. Yeah. This, number 2, times this number, negative 2. Okay? Negative 2 times 2x, negative 4x. Right, 2 times negative 1 is negative 2.
So now you have to do the separating. No, that's only if there's a variable.
Yep. So now you just yeah. Yep. Where is it? Okay. Okay, this one, and then we'll move on, and we'll end just in time. Okay. It's g of f of x. Okay, here. F of g of x, right? So f of x is 3 over x minus 2. So x becomes g of x. Here is my x. 3 over, 7x minus 2. Ah, you're right. You just stop there. Because wait a minute, is it asking for restrictions? Oh, it says state and domain. Okay, it's fine. You don't have to because it doesn't say for the restriction. It's fine. Let's just leave it that way. Okay, g of f of x, right? So g of x is out here. 7x. X becomes f of x. So here's my x. So this is 7 times what's x? Ah, okay, what happens here? I have something times something else. This is 7 over 1, yes. So it becomes 21 over x minus 2. Multiply the tops, multiply the bottoms. This one? Okay, so g of x is 7x. Okay, x is going to become f of x. Okay, x, so 7 times x becomes f of x, which is 3 times x minus 2. 3 over x minus 2. Yeah?
Yeah.
Now we're going to multiply. So you make this over 1, multiply the tops, multiply the bottoms. All right.
So it's G of f of x.
G of f of x equals 21 over x minus 2. Okay. Now, fresh functions. This time I have f of x, g of x, and h of x. Because why not? Okay. These are now g of h of 2. Now these are the brackets that Molly likes, right? G of h of 2. Okay. This time we have a number inside, not an x, a number. So actually, this is a lot more straightforward, I think. What we do is these. For this, we have to start from the inside. Okay, start from the inside. So, take a look here. What's inside h of 2? Okay, we can find h of 2, right? H of x is this. H of 2 is here, 2 squared minus 1, right? Everybody okay with that? So we want h of 2. Okay, let's do this again.
Oh, 2 replaces that.
Right. Okay, I have h of 2. So I'm going to use h, right? Well, h of 2, yes, x becomes 2. So 2 squared minus 1. H of 2 is 4 minus 1, 3. Now I go back here. I have g of h of 2. What did I just say h of 2 was? 3. Okay, so g of 3 means now I'm going to use g of x. So I take the 3 and I put it inside the x for that. So it'll be 3 times 3 minus 1, 8. So 9 minus 1, which is 8. You just say 8, don't worry, because it gets complicated, huh?
Just write 8.
You just write 8.
Even for the other ones too.
For the top one?
Yeah, are you these?
Yeah, these, because it's only one. So for the other ones, in each question, you were asked for 2 things. It's good to differentiate. Okay, let's do this one. We're going to start from the inside. We're going to start with h. H of negative 3. So I'm going to take negative 3 and plug it in here. And here's where things get messy, because I bet you 70% of you will not put parentheses, and then there will be a negative problem. So if it's h of negative 3, I do negative 3 squared minus 1. Do you see how my negative 3 is in parentheses? If you don't put it in parentheses, it will be wrong. Now, how much is that going to be? Is it 8 or is it negative 9 or like negative 10? 8, right? Because this is positive 9 minus 1. If you don't put parentheses, that's where you'll be wrong. So this is 8. So now I go outside and I want f of 8. F of 8 is just 2 times 8, 16. Isn't that cute?
So fun.
These are so much fun. I love these. They're like little puzzles. Like you take it, you put it, well, half. It's, you know, a little bit of everything. Okay, h of f of minus 1. Okay, so f of minus 1. 2 times minus 1, negative 2. So then I go outside, h of negative 2. Minus 1.
Oh, minus
3. Don't we love these? Okay, so the next one you're going to do completely on your own. On your mark, get set, go. F of g of 3, go. All right, awesome. And then, you know, that'll be the end of this lesson.